morning, ladies and gentlemen. My name is Dr. Don John. I try to do it fast, but I just can't do that. I'm too tired. So my name is Dr. John Belkowitz. I'm the Director of R&D at Intelligent Concrete, where we specialize in doing the impossible with concrete. And our question today hinges on that. First and foremost, who did we get this question from a week ago? I've been traveling. Anyway, so the question is from Subi Nath. Thank you, Subi. Hopefully I'm saying that right. Hi, John. I Googled UHPC and got the result, ultra high performance concrete. What is ultra high performance concrete in your point of view? Can colloidal silica incorporate with UHPC? Have I faced problems for colloidal silica addition as an SCM? Whew. Subi, that's a lot, but it's a good thing you're talking to me. Bakak! That's right. The experts. No, in all seriousness, let's take every question one by one. You ask, what is my point of view on ultra high performance concrete? And my point of view is based on a few things. There are actually some really good definitions on ultra high performance concrete that's been put together by the American Concrete Institute. I believe it's, and can you look this up? I believe it's ACI 239, ultra high performance concrete. And the folks who are in charge of that committee, absolutely awesome. And I believe the definition of UHPC ultra high performance concrete includes a compressive strength at or above, I want to say it's either at or above 13,000 or 15,000 PSI. And I've seen examples between 17,000 and 22,000 PSI. And Subi, I'm guessing you're working with MPA, so 17,000 PSI is 117 MPa, and 22,000 PSI is 152 MPa. And a UHPC definition also includes fibers, fibers of some content. And there's also a great definition of UHPC in the ACI CT18 manual, which is on concrete.org, which is the website for the American Concrete Institute. So great set of definitions. And looking at ultra high performance concrete, which we design a lot of it and work with a lot of materials, and yes, colloidal silica is a great material to use for ultra high performance concrete. But to me, it's that high strength, but it also needs a high compressive strength, your F prime of C, that greater than 15,000 PSI. But it also needs to be a tough material too. If you're creating a material that's primarily has a high compressive strength, but it only has 10% or even lower on the direct tensile strength or the flexural strength, to me, you're not really achieving much. I mean, yes, you're making a strong concrete, but with that reduction in toughness, you have an increase in brittleness, and you have a lower resiliency to chemical and physical attack. And that's what we often see with ultra high performance concrete, especially with freestyle durability. So I think that there also needs to be an inclusion of new and emerging technologies outside of steel fibers to make that ultra high performance concrete more durable. Now, colloidal silica can be used, but normally it's not the bare-based colloidal silica. It's a modified version, whether it's aluminum modified or some type of other modification, to make that hydrated cement matrix at a much smaller level, microstructure level, more resilient to atomic dislocations and localized stresses that would ultimately be the catastrophic forces to overcome the tensile and shear capacity of the concrete. So colloidal silica can help with that, but it's a very difficult type of chemical that'll help with that toughening agent. Outside of that, using the colloidal silica as a supplementary cementitious material is a great avenue, specifically looking at it as either a replacement of or addition to the micro silica, looking for a gradation envelope. And I really hope Tyler Lay gets into a project. Using colloidal silica as an SCM is fantastic. I feel like I've gone over that in detail in a lot of other of our colloidal silica. But that being said, we've used colloidal silica anywhere between 2 to 20 ounces per hundredweight, depending on the particle size, as a replacement or as in addition to both microsilica, silica fume, as well as class F fly ash, or even C ash, or metakaolin, blah blah, the list goes on. So yeah, there's some great research out there, not only by us, but other folks on using colloidal silica as an SCM, and you can definitely use it as an integral agent in your UHPC design, either as a strength agent for compressive strength, you know, the shear tensile strength, densification, cement efficiency, or even resiliency to segregation if you by accident add a little bit too much water to these high chemically induced concretes, so high chemically made concrete. So Subi hopefully answered your question. Thanks again, bud. Don't forget to like and subscribe. Ding the bell for notifications. Go concrete!
Beat asphalt!
A little slow on the uptake there.